a gas giant called WASP-76b, discovered in 2020, about 640 light-years away in the constellation Pisces. A bloated world nearly twice the width of Jupiter despite weighing about the same. It orbits its star so tightly that a full year there lasts less than 2 Earth days, and it's tidally locked. One face stares at the star forever, while the other drowns in permanent night. On the day side, temperatures climb past 2,400 degrees Celsius, hot enough to boil metal. Iron doesn't just melt here, it evaporates and rises into the sky as vapor. Then winds screaming faster than 18,000 kilometers an hour drag that iron vapor around to the cooler night side, where it condenses and falls. It rains molten iron. Stand on that dark hemisphere and you wouldn't simply be burned. You'd be showered in droplets of liquid metal falling out of a black sky, in a storm that never, ever ends. But that's a place that announces itself from a distance. The truly frightening ones give you nothing to see. Which brings us to the planets with no sun at all. When a solar system forms, it doesn't always hold together. Gravity flings some worlds out into the dark, and they never come back. These are rogue planets, frozen, lightless, drifting through the galaxy completely alone. Here's the part that should unsettle you. A 9-year survey suggested there may be more of them than there are stars in the entire Milky Way. Billions. On some estimates, trillions. And we can't see them because they give off no light. The only way we ever catch one is the split second its gravity bends the light of a distant star behind it. Which means the galaxy could be crowded with silent, wandering worlds slipping through the dark near us, and we'd have absolutely no idea they were there. Some may even hide oceans beneath kilometers of ice, warmed only from within. NASA's next Great Space Telescope is being built partly to hunt them, and it may push the count from billions toward the trillions. But a rogue planet is cold and quiet. Turn one into a star, and everything changes. Take our nearest neighbor, Proxima Centauri, just 4.2 light-years away. It sounds almost cozy. The closest star to the Sun, with a roughly Earth-sized planet sitting right in its habitable zone. But this little red dwarf has a violent temper. In 2016, astronomers caught it firing off a superflare that briefly made it 68 times brighter, bright enough to see with the naked eye. A year later, another flare brightened it 1,000-fold in just 10 seconds. These aren't gentle. A single one blasts that nearby planet with ultraviolet radiation around 100 times stronger than what it takes to kill the toughest microbes we know of. And they come often. Frequently enough that the planet's ozone layer would never get the chance to recover. Over billions of years, flares like these could have stripped away its atmosphere and sterilized its surface completely. Our closest stellar neighbor may already have cooked its own worlds. But at least it stays put. Not all of them do. Because roughly 70,000 years ago, a star came to us. It's called Scholz's star, a dim red dwarf, less than 1/10 the Sun's mass, traveling with a brown dwarf companion. It plunged straight through the outer edge of our solar system, passing within about 0.8 light-years of the Sun, right into the Oort cloud, the vast shell of comets that surrounds us. That's the closest any known star has ever come, 5 times closer than Proxima Centauri is today. Early humans were alive to witness it, a faint red point that occasionally flared bright enough to catch the eye. And here's the disturbing part. We only found out it happened in 2013. For 70,000 years, nobody knew a star had walked straight through our cosmic backyard. Some distant comets still carry the gravitational scar of that visit. Today, it has drifted back out to about 20 light-years away, in the constellation Monoceros, but for a moment, it was practically on our doorstep. It came, it left, and we discovered it long, long after the fact. Now imagine one that hasn't arrived yet. Because one is coming. Its name is Gliese 710, an orange dwarf around 60 light-years away. And thanks to the Gaia spacecraft, we know it is heading almost straight for us. In roughly 1.3 million years, it will pass within about 0.166 light-years of the Sun, 25 times closer than Proxima Centauri is now, and far deeper into the Oort cloud than Scholz's star ever reached. When it arrives, it won't strike us. It'll do something quieter and worse. Its gravity will stir that distant shell of comets like a hand through still water, and over the following few million years, it could send waves of them tumbling inward. Roughly 10 new comets a year, in a bombardment that could last 3 to 4 million years, some of them on paths that cross Earth's. Of every star expected to pass near us over 10 million years, Gliese 710 is the single most disruptive. At its closest approach, it would blaze brighter than anything else in the night sky. A slow-motion collision we can already see coming and cannot do a single thing to stop. But a passing star is survivable. A dying one is not. Take a star more than 100 times the mass of the Sun and push it to the brink of death, and you get Eta Carinae, about 7,500 light-years away. This thing already faked its own death once. In the 1840s, it erupted so violently that it briefly became the second brightest star in the entire sky and hurled off more than 10 suns worth of material, carving out the glowing homunculus nebula around it. An eruption now thought to have been triggered by 2 or more stars merging. And then, impossibly, it survived. People across the world watched it happen and lived to tell it. Astronomers call it a supernova imposter. But the real explosion is still coming. When Eta Carinae finally detonates, it may not just go supernova. It could unleash a gamma-ray burst. Twin beams of radiation, the most violent event in the universe. The good news? Its poles appear tilted away from us, so the beam should miss. Probably. And at 7,500 light-years, even a direct hit would likely be too faint to end us. But some dying stars don't wait to explode to be dangerous. Some are dangerous while they're still just corpses. Deep inside our own galaxy, 30,000 light-years away, sits the burnt-out core of a dead star called SGR 1935-2154. It's a magnetar, a neutron star wrapped in the strongest magnetic field in the known universe, trillions of times more powerful than Earth's. Drift within 1,000 kilometers of it, and that field would tear straight through the electrical signals keeping your body alive. But you don't have to go near it to notice it. On the 28th of April 2020, this thing screamed. It fired off a fast radio burst, a flash lasting a single millisecond. So powerful it was the first ever traced to a source inside the Milky Way, releasing more energy in that instant than the Sun does in years. For a heartbeat, our own galaxy fired a shot bright enough to be seen from another one. But even a magnetar is something you can point a telescope at. The next one, you can't, because the most frightening objects in space are the ones you cannot see at all. In 2022, astronomers found the closest known black hole to Earth, Gaia BH1, about 1,560 light-years away in the constellation Ophiuchus. They never saw it, because you can't. They found it by watching a perfectly ordinary sun-like star wobble in space, quietly circling something invisible with the mass of 10 suns. It gives off no light of its own. It's dormant, sitting utterly silent. That tiny wobble is the only reason we know it's there at all. And here's what should keep you up. Our galaxy is thought to hold around 100 million black holes, and the vast majority are dark, isolated, and completely invisible. Statistically, the nearest one might be just 20 light-years away, drifting silently through the dark, and we would have no way of knowing. Gaia BH1 is a small one, only 10 suns. But size, as it turns out, is not the terrifying part. Take a black hole and turn it into a monster, and you get Phoenix A buried at the heart of a distant galaxy cluster, one of the most energetic ever found. This is the largest black hole humanity has ever discovered, around 100 billion times the mass of the Sun. That's roughly 24,000 times heavier than the giant at the center of our own galaxy. It may sit right at the theoretical limit of how big a black hole can even become, and it likely grew to this size within the first 100 million years after the Big Bang. Its event horizon stretches about 4,000 times the distance from the Earth to the Sun, 100 times wider than Pluto's entire orbit. Drop our whole solar system inside it and it would vanish without leaving a ripple. And it is still feeding, swallowing roughly 60 suns worth of matter every single year. It makes every black hole you've ever heard of look like a pebble. But not everything terrifying out here is enormous. Some of it is small and silent and impossibly cold. About 5,000 light-years away in the constellation Centaurus, A dying star is exhaling its outer layers into space at 500,000 kilometers an hour. As that gas rushes outward and expands, it cools. The same way a spray can turn cold when you release it, dropping down and down to just 1 degree above absolute zero. This is the Boomerang Nebula, and it holds a title that sounds impossible. It is the coldest known place in the entire universe. It is actually colder than empty space itself, colder than the faint afterglow of the Big Bang, the background warmth that fills every corner of the cosmos. Nowhere natural comes closer to the absolute bottom of temperature, where atoms themselves are almost frozen still. It is a pocket of the universe more frozen and lifeless than the void around it. But even the coldest, stillest place is playing by rules far larger than itself. And right now, those rules are already dragging us somewhere. Right now, without feeling the slightest thing, you are moving. Our entire galaxy is being hurled through space at more than 2 million kilometers an hour towards something we cannot see. For decades, astronomers called it the Great Attractor, an immense mass more than 100 million light-years away, at the heart of our home supercluster, Laniakea, a web of some 100,000 galaxies all being dragged toward it. The problem is that it sits directly behind the crowded, dusty center of the Milky Way, in a region we literally cannot see through. After decades of study, we still don't truly know what it is. And in 2017, the story got even stranger, because it turns out we aren't only being pulled toward it, we're also being pushed from behind, shoved outward from a vast, near-empty patch of sky on the opposite side of the heavens. Dragged towards something invisible, driven by something empty, our whole galaxy caught in the middle, and there is nothing anyone could ever do about it. But even this is nothing next to how it all finally ends. Which brings us to the final place, the one that isn't a place at all, but a moment. The universe is expanding, and a mysterious, invisible force called dark energy is driving that expansion faster and faster. If that force keeps strengthening, everything ends in something called the Big Rip. First, the great clusters of galaxies are torn apart. Then, tens of millions of years later, our own galaxy comes unglued and scatters. In the final few months, the solar system is ripped open and the planets fly loose. The Earth itself breaks apart roughly half an hour before the end, and in the last fraction of a second, atoms, the very things you and everything you love are made of, are pulled apart, and physics simply stops working. We don't know for certain that it's coming. The universe might instead simply grow cold, dark, and empty over countless eons, because we still don't understand exactly how dark energy behaves. We don't know when it might begin. And, like everything else out here, there would be no warning at all. So enjoy the quiet while it lasts, and subscribe before the universe does something about it.